we have extracted the scope of the work, right? So scope of the work for this particular project, what I did, like from the planning department of the project, I have taken of the bill of quantity. So from the bill of quantity, I can take out what is the scope of work. Right? Next, the company is having around 4 to 5 previous project done in the same city. Right? So they are having a basic productivity chart. So we are going to also refer the same productivity chart for our references for doing the planning. Okay. So we have taken a scope of work from their BOQ, right? We have taken their productivity chart from their company's basic labor productivity chart. From there only we have taken into the element. Okay, in fact, now this is very very important, right? What is the issue we are having? Let's try to understand it, right? What is the concern or what is the issue we are having? What happened? I will tell you. When we are doing any kind of a project planning, okay. So when we are doing a project planning at an initial stage, we are not having all the details of the working drawing. We are not having all the working drawing details, right? But definitely, yes, do we have some of the typical plans, working drawing, layout details maybe we are having. So on the basis of that, approximately I can able to calculate the quantity, right? For example, if there is a 8 floor building is there and they have given me the layout plan, right? So I know the what will the slab thickness, which is typical. So I know the in the layout they have put it around the column. So I know that how much the column is going to remain the same till the 8 floor. So how much the quantity is that I can calculate, right? So I'm able to calculate all other quantities. Like you can talk about concrete, you can talk about brickwork, different elements. Whatever the elements I'm going to require, even the waterproofing, I can talk about the waterproofing can also be taken care, because once I know the slab area, I can see what is the final floor. On the basis of that, I can calculate the waterproofing. Right? All these materials I can take out the quantity in that. But one of the issue which we face specifically in the planning is steel quantity. Okay? Because in the drawings, generally whatever the elements they have given me, just take a case of the concrete. My audio is not there. Are others are able to hear my voice? Okay, audio is good. Okay. So Javed, just do a refresh. I think there may be a small fluctuation. Okay, fine. Thank you. Everyone. Now, the issue which we face into the site planning, right, is that all of the materials I can find it out from the what we called it, layout drawings or all the typical drawings. I can find it, right? But the issue is facing in the steel quantity. Sir, you may ask, sir, what is the reason? What is the difficulty you are facing in the steel quantity? It is simple, na, sir. Right? The reason is that even if they have given me the section or the reinforcement details into my plan section, right? For calculating the steel quantity, I need to go through the BBS, bar bending schedule. And for doing that bar bending schedule, I should be having all the reinforcement details of my structure, but which I'm not having right now in the initial stage. So that is one of the difficult phase we are having. So let's first learn, right, how to do the steel quantity planning. So that we are going to learn first in the first preliminary stage, right? So what I did is I have taken a scope of work from the site directly. So different elements I have put it around. Like for example, excavation is 3,821.40 cubic meter, right? PCC is 117 cubic meter. Foundation is 340 cubic meter. Similarly, you have seen, right? So different element is having a different of uh, quantity. Okay, so it may be a column, it may be beam of floors or the floors of different quantities. In the next, I have already written the shuttering quantity also. So concrete quantity or whatever the element quantity and even the shuttering quantity other than the excavation, because excavation is not going to have any kind of a shuttering quantity. Now see the below table. Now above table is I have directly taken from the site. So on this basis, we are going to do the planning. I'm going to which the case study right now I'm taking. I'm going to do the planning on this particular part, right? But the below table is very, very important, right? So what this table is saying, that we need to understand first before starting the, like, before solving the case study into this particular case, right? Now what they're saying, see, they're saying, take the first element, slab or the lintel beam. Right? So the range for reinforcement for a slab or a lintel beam may vary from zero point 0.7 to 1%. It may vary from zero point 0.7 to 1%. But it may vary from that, but right now I'm going to take any 1%. Like, so I'm going to take for making my calculation so that everyone will be on the same platform, or everyone is going to get the same answer. So I'm going to consider the 1%. So if I'm going to take the slab quantity, I need to calculate the steel for slab quantity. I'm going to take as a 1%. So 1% of steel quantity per cubic meter of concrete. Getting my point? So 1% of the steel quantity per cubic meter of the uh, concrete, right? I'm going to show some numbers solve also so that you can able to understand. Don't worry. First, let's understand the basic concept. I'm going to make sure one thing, you're going to understand all the concept, but just be with me. Let's understand step by step, right? If I'm talking about a column, so percentage may vary from 0.8 to 6%. 0.8 to 6%. So right now I'm going to take, if anyone is going to ask me for the column steel quantity, I'm going to take right now for a 2%. So that everyone, you can take anything between zero point 0.8 to 6. But now when I'm going to solve some of the numerical, so everyone should get the same answer. That's why I'm putting this third column. That is, I'm going to consider the 2%. But it depends on your site condition. You can take zero point 0.8 if the G plus 1 or G plus 2 is there. If the structure is high, you can go for a 3%, 4%. That depend upon. Okay. Next is the beam. You can take anything between 1 to 2%. So right now I'm going to take as a 1.5%. Foundation, you can take somewhere around 0.5 to 0.8%. Okay. So here I'm considering as a 0.5%. Now I am having a question here. Very interesting question. Just a moment. What I'm experiencing here is, okay, this is a very interesting observation I'm telling you. Yes. So I have put that question. When I am seeing for a different structural material, na, how we are going to learn how to solve that element, right? But when I'm seeing for a slab, the percentage is varying from zero point 0.7 to 1. So very slight range is there. When I'm talking about a beam, 1 to 2 percentage. 1% is the range. When I'm talking about a foundation, zero point 0.5 to zero point 0.8, very small range. But when I'm talking about a column, the range is very diverted. It is going from zero point 0.8 to zero point 0.6. So what may be the probable reason why there is a huge range here in this particular case? What may be the reason? Put it around into the poll. Why you think the column is having the such a drastic range as compared to any other structure, other memory? Okay. Okay. Good enough, George. Okay. Good enough. Okay. Columns anchor the building, hence need the strength. Okay. Carries too much of load. Okay. Probable it is the main structure member and will carry a larger size of the rebars. Okay, good enough, good enough. Because of the foundation in the ground and the number of supports. Foundation in the ground and the number of supports. Okay, fine. Good enough. Good enough. Now, we need to understand some basic things in that, right? What is the basic understanding or what is the basic thing we need to understand? We are just saying when I'm taking any kind of other structural member. Okay. So in that particular case, if I'm talking about a slab or a lintel beam, okay, so the range is very less, right? When I'm talking about a column, the range is very, very, very high. The reason is that we need to understand whenever the load is transferred, okay, so whenever the load is transferred, so that particular case, from the top floor, like just take an example of a 15-story building. Take an example of a 15-story building, right? If I'm going to ask, like on the 14th story, right, the 14th story column is going to bear the load of that particular floor and even the above floor. So as I'm going to move in the lower and lower floors, for example, I'm talking about a 13th floor. So there 13th floor self floor load plus 14th floor plus 15th floor. Similarly, when I'm moving to the downward, every floor is going to take a load of their above floors, right? And whenever we go for a multi-story building, because the more number of the floors are there, the load will be more on my column, which is not a case in any other structural member, and that is the reason I'm going to have a most variation into the column. If the it is having bungalow or G plus 1 only, I can go for 0.8 to 0.9 percentage. Right? Once I go for a 4, 5, 6 story, I can go for a 2%, 2.5%. Similarly, I need to put it around. Getting the point? And that's why column is going to have the maximum range into the steel part. Okay, sorted out. Concepts are clear. Right? Now let's try to put it around the how to calculate. I'm going to tell you how to calculate it so that this percentage will be clear. But did anyone have any doubt into this particular slide? Because you may have some of the doubts, and I'm expecting some of the good questions so that we can able to do a more discussion. Like anyone is having any doubt? If you're not having a doubt, you can say no. If you have a doubt, you can put it around. Okay, Sonny, you having some doubt? No. Okay, fine. Yes, that is because of the load carrying capacity. Because as the number of stories increasing, there will be a more load on my bottom columns, right? So they need to bear a more load. That's why the steel quantity is increasing. Yeah, fantastic. Good enough. I'm expecting some of the good questions, right? So let's take the example of the Nebin first, right? How this range is defined. That is very important. Now, the question will be put into this form also. From where you get this range? Basically, you're asking this question, right? So we need to understand very important basic concern is this range is as per the Indian Standard Code, right? So Indian Standard Code or the IS standard not saying that this should be the range. What they are saying, now we need to understand, right? For example, just take a case of a column. So the column, the IS code says minimum percentage of the steel as per the IS code should be the 0.8% and maximum percentage of the steel should be 6%. So what we are understanding into the different form, minimum and maximum percent of the steel is the range of my steel percentage into my column. So from there we derive this particular range. Getting the point? Okay. Now next question is, so any question like the why the range is 0.8 to 6. Okay. So now you want to say why it is not going for beyond the less than the 0.8. right? And why the maximum limit is 6%? I think that is the question you want to ask it, all right? So now we can put it around. I will give you example with the help of slab. Okay, that is going to sort it out all my question, like so that you can able to understand into the similar way for the column. What happened whenever any standard code putting minimum standard for anything, right? I will tell you a case of a slab. Right? If I'm going to refer the IS code now, so IS code says the minimum slab depth, right? Minimum slab depth will be the 100 mm. Now there may be a question, sir, why 100 mm? Right? It may be